This training session is on the fundamentals of transformers. More specifically, we're going to look at the connections and protection of transformers. Now, this course is about 4 hours in length, and you can take it in stages if you want or all at once. It's up to you if you want to do it a chapter at a time or even a partial chapter at a time. It will be available at all times to you to review the various chapters and then go away and come back if you want. The course starts out with a review of electromagnetism and the quantities and formulas and the theories and laws associated with electromagnetism and how they relate to transformers. Because electromagnetism, let's face it, is a very fundamental part of transformers. That will lead us to having a look at the ideal transformer, and then we will move on to what is known as, or we will call the real transformer, which will include losses and leakages and how we represent it in electrical diagrams. We then will have a look at instrument transformers, potential transformers, and current transformers. We will then move on to three-phase transformers, starting out with the core construction and how the three-phase transformers are put together. We will look at configurations such as Y to Y and delta to Y, and we will also look at the complex Y to zigzag transformer and the reason behind using it. We're then going to look at the protection of transformers, everything from fuses to differential protection. We will then look at cooling, and we will look at a mechanical protection device called the Buchholz relay, which is made to monitor the gas accumulation in a transformer. And finally, we will look at oil analysis in a transformer, which is fundamentally important to maintaining power transformers. As I said, we are going to start off with a quick review of electromagnetism. Included in that review will be reviewing the designation of how we describe various quantities when examining electromagnetism, including magnetic lines of flux and flux density and the various units that are used to describe these magnetic quantities. We will also be reviewing the laws associated with electromagnetism, such as Faraday's law and Lenz's law, and how changing magnetic flux lines around a coil will induce voltages and currents in a coil. That will lead us to the development of the ideal transformer, which will be used to study transformation of two-winding and three-winding transformers and having a look at such things as turns ratio and how to predict the secondary voltages with respect to the primary voltages and the currents involved in the primary and secondary as well. From there, we will move on to the real transformers and how they are constructed and the various things that we have to take into account when we're dealing with real transformers as opposed to ideal transformers. And there are things that have to be taken into consideration in the real world, such as the losses associated with a real transformer, including copper losses, leakage flux losses, eddy current losses, hysteresis losses, etc. As part of the development of the real transformer, we're going to be looking at some special transformers that are called instrument transformers, and in this case, it will be the two types of instrument transformers that are primarily used out there: current transformers and potential transformers. We'll be having a very close look at how we describe the polarity of these transformers. Starting with the current transformer, we will look at how they are marked so that we can predict how the secondary currents will react with respect to the primary currents. We will also be looking at potential transformer polarity as well, and we will see again how they are marked and how we can predict the polarity of the secondary of potential transformers with respect to their primaries. We're also going to, before leaving instrument transformers, we're going to look at coupling capacitor voltage transformers, because they are a little bit different than others, but they're very prevalent out there, so we will have a look at them as well. We're going to look at transformer connections. We're going to look at the basic Y to delta, delta to Y. We're going to have a look at how the various phases are affected by their various connections. We're going to establish the fact that there is a 30-degree phase shift when dealing with Y delta or delta Y connections on a transformer. We're going to move on to having a look at the Y zigzag transformer and the need for using zigzag transformers in the modern day distribution system. We're then going to look at transformer construction in its basic form, looking at everything from the tank containment and the oil and how the low voltage windings and the high voltage windings are wrapped on the laminated steel core, and then the terminals are then brought out in the form of bushings on a power bank. We're going to look at cooling of transformers. Certainly in the case of transformers with losses, there's a great deal of cooling required to keep the transformer operational, and we're going to look at the various methods of how that is done. As we get into transformer connection, we're going to be looking at fuses and how fuses are used in the distribution transformers, and we're going to have a quick look at the time current curve and how fuses are used to coordinate tripping and protection of transformers. We're then going to move on to relaying, and we're going to look at differential protection, and more specifically we will move into how a three-phase transformer differential protection is connected and how it works. We're then going to look at some practical applications, and we're going to look at some old school relaying because there's still a lot of them out there. And we're going to see how they are connected into the system, how they relate to the theory that we will be developing. And then we'll move on to the more modern type relays, which are the IEDs or the intelligent electrical devices. And we're going to have a look at 3 examples of the many of them that are out there in the world today. As we get closer to the end of the lessons, we will have a look at a mechanical protection device called the Buchholz relay, which does react to gases in a transformer, and we'll see how they're connected and how they work to protect the transformer. And lastly, we're going to look at dissolved gas analysis or oil analysis in a transformer, because that is a big part of transformer maintenance. We will leave that to the end, but we will review the various items under that heading. And this brings us to the end of the introduction in regard to transformer fundamentals.